Okay, suppose I have a set x that's number between 1 and 0, so I can draw something like this. Suppose I have a second set between 0 and half, so it's something like this. And then I have a third set between 0 and 1/3, so it's something like this. And I keep going on until the end of the world. I'm saying all these sets do not share a common element. So what does it mean? For example, I have a set S like this, right? Suppose I have a set T equal to just B. So B and T do not share common element because B exists in T, but B does not exist in S, right? Because I just saw about it last time. Okay, so these two sets do not share a common element. This particular example is easy because you will say, oh, it's trivial. They don't look like the same, so they do not share a common element. This example is crazy. This example, I'm giving you some set that looks like the same thing, but they do not share a common element. When we see infinity, crazy thing happens, and do not use common sense to think about infinity. Okay, this is the first example. How do we prove it? Prove by contradiction. Suppose I said this set have a same element I call E. And if you look at this picture, this set are going to become getting smaller, 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 and smaller. So I can say the E is just this corner. Okay, that means E is here. Let's say that number 2, E belong to all the set, right? So I think they are this corner point. So E should fulfill all the definition here, right? Because what is a set? Set is something that a proposition is true, right? So all this thing is true. That means E is between 0 and 1, E is between 0 and half, E is between 0 and 1/3, and so on. So the second sentence means all of them have larger than 0, right? So E is larger than 0. Third statement, if E is larger than 0, you can always find a big enough n such that 1 divided by n is smaller than E. Here's a funny thing. Then by 3, that means E do not belong to this particular set. Notice that I have dot, dot, dot. That means this goes forever. That means in the end, when I reach the set that is exactly with this n, then the E is not inside that set. But I have assumed that E belongs to all the sets. So contradiction between sentence 4 and sentence 1. So if I see contradiction, that means the assumption is false. That means this whole sentence, the negation is true. That means they do not share a common element. That means if I have a set that looks like this, which is simple stuff, they look very similar to each other, but they do not share a common element. Just a note, if I draw 2 stars here, it means difficult. Now, proper subset. We said that A is a subset of B if for all x, x in A implies x in B. Okay, then this means it's possible A equal B. We add a not equal here, so this means subset. These 2 lines looks like equal sign, so people are just so lazy, they just write this because you know this means not equal, right? So this is the symbol. So what does it mean? It means for all x, x in A implies x in B, exactly what I said here. But now we also have a new thing. There exists something is in B but not in A. This is the new thing. Without this, only this part, we don't have the red thing. We have the subset symbol. And for subset, there are the trivial subset that is called nothing set or empty set. These 2 important. They are the same thing. Okay, they are just 2 symbols writing the same thing. This is called empty set. This is basically writing the 2 brackets and then say there's nothing inside the empty set. Okay, and since nothing is always belong to everything, so this is always a subset of any set, including itself. Okay, but nothing is not a proper subset of itself because proper subsets do not allow equality. So you cannot say nothing equal to nothing for the proper sense. Nothing is a subset of nothing, but nothing is not a proper subset of nothing. Nothing is a proper subset of anything that is not nothing. And then how do you prove 2 sets are equal? You prove what? A belong to B and also B belong to A. It's the same as in the number sense. How do you prove 2 numbers are equal? You prove this number is larger than or equal to B, and you prove B is also larger than or equal to A. And since these 2 hold at the same time, then they can only be equal. Right? This is the same idea. So this is in the logic sense. This is also in logic sense. So here is an example. I have a set X defined by this equation, and I have a set F defined by this expression, and I have a set defined by this expression. In this particular example, they are all the same thing. First of all, this set and this set are the same thing because everything belongs to E, which is just 1, 2, also belong to F, and everything belong to F, which is 2, 1, also belong to E. Okay, so they're the same thing, fulfill this sentence. These two sets are same because in set we don't care about duplicate element. So 1, 2, 2, 1 is just 1, 2. We don't care about duplicate. In very advanced case, we care about duplicate. Those are called multi-set. We don't talk about that. But in this case, we don't consider duplicate element. Okay. So because this guy is just 1, 2, which is just F, so therefore they are the same thing. And then example, if I have this particular definition, a set of x such that x to the power 4 is 16, so we know it's 2, but x is odd. There's no such thing, so it's empty set. Now you see 2 star, this is a funny thing. X equal set of nothing. So first of all, as I just told you, nothing, empty set is a subset of any set. Okay? And then what is this sentence? Well, this sentence looks weird, but don't forget the blue box is x because of the blue box. So this sentence is saying that x is subset of x, which is true, right? I just changed name. Okay? And then this is funny. This guy contains nothing. What is this guy? X have one stuff inside, which is nothing. So this is true. Because x contains one element and nothing contains empty, nothing. So you cannot say this. Let me recall what is the subset mean. Subset means for all x, x in A implies x in B. So for x, nothing is in x, but is nothing inside this? No, because nothing is defined as nothing. There's nothing here. You cannot put a stuff here. And you now here have a stuff. This stuff have the same symbol. We don't care. We just say there's a stuff there. Okay. So therefore we have this. And then now we have this. This is just from here, right? And then this thing give us here. So that means this is false. If A is equal to B, only if these two sentences are both correct. But now I only have one part. Therefore, this I show that nothing is not the same as a set of nothing. This is empty set, means it's a set, but it contains nothing. This is not empty set. This is a set, contains one thing, and that particular thing is the empty set. Okay, so this is also the explanation why B is not set of B. If you allow this to be true, crazy thing will happen. So this is 2 star. And therefore, how do we prove two sets are not the same? Just this. Done. This is an example how you prove two sets are not the same. And this you have 3 possibilities. You read it by yourself. Now here's the other one called power set. In some book, they write PA. I don't like this. I just write 2A because it looks like power, right? 2 to the power 3. You write 2A means the power set. What is power set? It is the set of all possible subsets of A. So what the heck is this? Let's look at this for example. A is 1, 2, 3. So what is the power set of A? All the possible combination of elements you can think of for A. Then the first guy is you pick nothing from A, this guy. Then what's next? You have 3 stuff. Then you just pick one of them. So I have 1 and 2 and 3. This 3 thing give me 3 set, which is this 3 guy. And then what? I have 3 stuff. I can pick 2 things. Then I have all the 2 things here. Lastly, I have 3 stuff. I pick all the 3 things, which is A, then A. This thing is the power set. Suppose I have a set A, which is defined by 1 stuff. I have a set B, which is the power set of A, and then I want to find a power set of B. That means power of A. I call it B, right? Power set is defined as all the possible you can form a subset from the given set. So A have only one thing. So if you pick something, you have to pick the whole thing. That means A itself. Or you pick nothing. So power set of A, which is B, is this. Okay? Then now I have this thing. I have a set with 2 stuff. That means if I want to find a power set of B, which is C, then I either pick nothing from here, so this is nothing. Pick the first guy, this is the first guy. Pick the second guy, this is the second guy. Pick both, which is just B. Okay, therefore I have this. And now, as I showed you previously, nothing and the set of nothing are not the same thing. Therefore, these two things are different things. Okay.
When you write C, it says one of them is a set of nothing and A, and another one's B. Are they not the same thing?
Yes, so this is duplicated. And so you can think of nothing is 0 and universal set is infinity. And here's a funny thing. By Russell paradox, this set does not exist. That means I have A, B, C, whatever, a bunch of set. I'm now saying, well, there will be a super crazy big set called U is universal, everything. It turns out this guy does not exist. Why? Because what happens if I have a set here is also U? Is U belong to U? Now I go back to Russell paradox, which no, therefore you cannot have that. So this set does not exist. And because even more crazy, if this set exists, then you can think about what about the power set of everything? And then what about the power set of the power set of everything? Right? Because I already said this contains everything. Then there shouldn't be a power set, because if there exists a power set which contains more stuff than this set, then this is not universal. This is contradiction. So therefore, this U does not exist. This is the similar kind of argument, like there does not exist infinity in number. Because every time if you give me a number, you call it infinity, I just plus 1. Now my number is bigger than your number.